Hello everybody, my name is Philip and I'm showing you guys my Minecraft ALU. So, I know you guys are building your ALU project in class and I decided to do it in Minecraft for a project. So, what this is you've got two 8-bit inputs. You've got the blue ones over here. They go from B7 all the way down to B0. And then over here you've got the yellow ones. A7 through A0, way down at the end. And these are the control bits that go in. And what this does is it does a mathematical operation or logic operation on these bits. You can control which operation is done with these levers. So if both levers are up, it'll add the two bits together, or two inputs together. If the left one is up and the right one is down, it'll AND them. If the left one is down, the right one is up, it'll OR them, and if they're both down, it'll multiply them. And then the output will be displayed over here on the outputs. So let's see, what do we got? Let's start with add. So both levers are up. We have over here, that's a 1 plus 4, so that's a 5 on yellow. And then over here, this is 5 plus 2 is 7, so 5 plus 7 is 12. So then we come over here and starting from the low one, this bit represents 1, this is 2, this is 4, and this is 8. So this is 8 plus 4 is 12, and that means it worked. Okay, and then next we'll do AND, just go down the line. So we switch the lever, it's going to switch to AND mode. And how this works is for each one of these blue and yellow that are the same, both are high, it'll output over here as high. So in this one, A0 and A2 are both high. And in this one, B0, B1, B2 are high. So since B0 and A0 are both high, the 0 over there will be high, and since B2 and A2 are both high over here, this one will be high, because they're both up. They're ANDed. And that's how that one works. Pretty straightforward. Next will be OR. So this goes down. That goes up. There we go. So now it's going to switch to OR mode. And as you can see, so this one has 1 or 0, 1, and 2, and this is 0, 1, and 2. So let's add like a 4 here. And it'll take a little while to propagate. So there it goes, updated in that one. Or takes the longest actually to update, so it'll be a little bit. There it goes. So now we have 0, 1, 2, and 4, because we have those over here. Now let's do the last one, multiply. Let's do a simple number. So let's say 5 times 5. So this is 5. That's there, and then let's set this to 5. Okay, because this is 1 plus 4 is 5. And this is also 1 plus 4. And then over here, it'll take a bit once it's done updating. There we go. So now we can add these together. So this is 1, 2, 4, 8, 16. So 16 plus 8 is 24, plus 1 is 25. So it did 5 times 5 equals 25. There you go. So that's how it works. The only thing left is status. Status is only used for the add function. We'll switch it to add. And that's for if you're adding numbers that produce a carry. So let's add two big numbers together. And then over here, I think that'll be big enough to go to carry. There it goes. So yeah, so we went to a carry. And then it'll update over here. Now it takes a little while to update. You'll understand why when you look over everything. The importance is each one of these little things here is called a redstone repeater. And it just boosts the signal to make it last, because the signal only travels 16 spaces. So if you don't have these repeaters, then it'll just fall off and stop. And each one of these has a tick of delay. A tick is about 1/3 of a second. So every time it has to go through this, it costs a little bit of time, creating propagation delay, which is why it takes a while. So now I've shown you the basic functionalities. You can play around with the levers and do whatever numbers you wanted, but we don't have too much time. So we'll just show you how it works. So that's pretty simple over there, that small area, but now we see there's a whole bunch of redstone that makes this baby happen. So going down way to the end, starting with the easy guys, we have the ore area. So this is what's doing the logic for all of the ores. You have the B's coming in here, the A's coming in here, and these just connect all the way back down to the A's and B's you saw at the start. These here are just for sorting and helping understand what these wires mean. So then they ore here, and then they do the output down at the back, and I'll show you the back at the end. Next up is AND. Up to view. So this works the exact same way as the OR, except at each point it's an AND gate for each one of them. So B0 and A0 go through an AND gate, and then that result goes out to the output. And this is created with 3 NOT gates. So this is a NOT gate, this is a NOT gate, and this is a NOT gate. And the important thing to know is whenever a redstone torch, this is a redstone torch here, receives power, it turns off the torch. And using that property, it creates a NOT. And with those NOTs, you can create all the other gates, and you can use all the universal gates, which allows you to do all of the other gates. I'm not going to go into too much detail on how this works, but you can see here this produces an AND gate. Next up is the adder. So this is an 8-bit adder. So this one's pretty straightforward, I think. You have A0N, B0N, and this is a full adder. So this whole block here is one full adder. The carry comes in over there, and then now this carry goes to the next adder. So this is another full adder. Now A1 and B1, and they add together, and then the next one, and the outputs of those little green ones over there. And it just does this all the way for 8 bits, passing the carry along, and then eventually the carry comes out here and goes to that status we saw earlier. So then, next is the big boy. This is multiplication. This is where it really gets fun. So the multiply actually only does 4 by 4. It's 4 bits times 4 bits. Because when you do 4 times 4 bits, it produces an 8-bit output. If you do it 8 bits times 8-bit, it would be a 16-bit output. Which, doing an 8 times 8 multiplier is this multiply. It's like 5 times as big, literally. So I might do it in the future, but for now I don't have an 8-bit multiplier. I only have a 4 by 4 multiplier. So won't go into too much detail just for time's sake. But basically, the idea here is you've got three 4 adders in a row. So these are 4 sets of full adders, and this creates a 4-bit adder together, and it's 3 of them in a row. And then you put all the inputs, and you put them in the right spots. I won't go into too much detail on how they go in, and they pass the signals along to the next one, and then to the next one. And ultimately, it comes out nice and clean at the end. After all that logic, you have your multiplication outputs right over here. Okay. And yeah, if you want, I think the teacher will give you the map. If not, you can look it up online. I don't want to make the video too super duper long. Okay, so next is the last part of just getting the signals back. So in order to do the opcodes to make it choose what type of function it's doing, there is over here, way up at the start, it's a 2-bit decoder, which will produce a 1 hot output. And it means that all of that output goes to one of these 4 areas, and the outputs of all of these are ANDed with one of the decoder outputs. So these are decoder outputs, and I'll go to the one that's on. I think 1 multiply. Maybe, I don't know. What are we on? No, we're on add right now. So you see this one is up. So that means that this decoder output is up and it goes to the AND here, which means that it will only put this output to the main display if its decoder output is chosen. And I don't know if that makes sense, but just trust me, it works. And then we have, this is the main pathway of the main display. It passes its signals onto the main display, and then it does the same thing for multiplication down here. And then we follow it all the way back. All the way back around. All the way back around. It's loading pretty slow. And all this comes all the way back around to here. So now we have all this done so that we can have our nice clean outputs right here next to our inputs. And that's pretty much it. I really encourage you guys to get experience with Redstone. It's really cool. It's a really good way to learn digital logic. So if this seems interesting, check it out. If it seems like this is impossible, there's no way you could do it, and there's no way you can understand it, if you're able to pass digital logic as a class, you can make this. It uses the exact same concepts of what you're using in class, but just applied to Minecraft. Yep. Anyway, have a good one, guys.